draw in a triangle and then the special properties that it has. Today we get 2 new segments in a triangle, okay? Before we do that, let's do the warm-up. So this one says factor w squared plus 13w plus 36. So anyone remember the method that we use to factor something like this? Does anyone remember the x method? We would need 2 numbers that multiply to that last number, our constant term is what that's called, and then add to our middle number, add to 13. So multiply to 36, add to 13. Anyone have any suggestions? What multiplies to 36? 6 and 6, okay, that's not going to add to 13. What else? 2 and 18, that's not going to add to 13. What else? If 2 fits into 36, what else probably fits into 36?
36.
No, well, 36 does, yes, but what's another even number? 4. 4 times what is 36? 9. Can 4 and 9 be added to get 13? Yeah, so those are my 2 numbers, 4 and 9. Okay. For problems like this, I just would recommend starting with your top number. It's a lot easier to look at what can multiply to 36 rather than what adds to 13. Okay. And then with that 4 and that 9, we do w plus 4 as one of our factors and w plus 9. So in Algebra 1, you probably called this the x method. You might have called it reverse foiling because we can FOIL this back out and get what we started with. Okay. Questions on that one? Okay. The next one, again, same situation. We need 2 numbers that multiply to what? What do our numbers need to multiply by? 21, that last number. And they need to add to negative 10. Just watching your signs, it's negative 10. Okay, multiply to 21, add to negative 10. Let's look at 21. What multiplies into 21? I can only really think of one number or 2 numbers. Does Max 7? 7 and Bella 3. Which one of those, one, neither, both, need to be negative to add to a negative 10 but still multiply to a positive? Both. Perfect. Negative 7, negative 3. If you have a negative down here and a positive up here, they both need to be negative. And then again, we just do t minus 3. T minus 7 as our factors. Questions on that one? Okay. So that was the warm-up. Now we're going to start talking about things kind of related to this poster over here. We have a bunch of special segments, and they're all going to intersect at special points in a triangle that we can kind of refer to as different centers of your triangle, okay? The one that we talk about today is actually going to be like the true center of mass, so we'll do like a cool kind of experiment with it. But when we draw all those lines in a triangle and they hit the same point, they intersect at a point, we call them concurrent, okay? And that point that they intersect at, so like all of these points right here, we call that the point of concurrency. Not a vocab word that you really need to know because we don't go into this unit in super much detail, but all of these kind of points that we're going to talk about are technically called a point of concurrency. Okay. Our first special segment of the day is called a median. Okay, so last time we had perpendicular bisectors and angle bisectors. Today we have a median. The medians essentially connect the vertex, one of the vertices of your triangle, to the midpoint of the opposite side. So if I have this triangle right here, my median is going to start at this vertex, and it's going to go down and hit the midpoint of its opposite side down here. So if you draw all of those, you get something that looks like this, starting at a vertex and then hitting the midpoint, okay? This point that they all intersect at, that's a point of concurrency, and there's a special name for it that I'll go through in a second, okay? But this segment right here starts at a vertex, hits a midpoint, because it breaks it up into two congruent pieces. So CB right here is a median. CB is a median of that triangle. This almost looks like a perpendicular bisector because it still bisects one of the sides of our triangle. But this angle right here is not necessarily 90. In this picture, it almost looks like it is, but it's not necessarily 90. And we'll see today on that little experiment that we do that it's usually not 90. Okay, so it is different than a perpendicular bisector. Something else to note is that, like I showed you in this little triangle, there's 3 of them per triangle. Okay? So that's a median. The point that the medians intersect at, so the point of concurrency, is called the centroid. Okay? So this little point on this yellow triangle is called the centroid. Or this point here, point P, on this triangle. Okay? This has all 3 medians drawn because it connects a vertex to the opposite midpoint, and they all intersect at that centroid. And here's kind of the cool thing about centroids. It's a little bit different from all of the other centers of triangles because this one is the average position of like all of the points on this plane or on this triangle. Do you have a pass? Oh, okay, cool. They didn't give you a pass?
No. It was the medium.
Huh? It was the what? Oh, okay. Okay. So the centroid is kind of the average position of all of the points on this triangle. That also means it's the center of mass. So if I accurately find my centroid of this triangle, and I try to like balance my triangle on that point, and I line it up perfectly, it's gonna balance. I don't know if I can do it very well. Okay, it's the center of mass. We're gonna try to do this with you guys and with different triangles. So this triangle was an acute scalene triangle. I have like 5 different types of triangles. I'm gonna hand them out with some scissors. I want you guys to, first step, just cut out the triangle. And then we'll reconvene after that. So step 1, just cut out the triangle. I'm going to give you and the people around you different types of triangles. So I'm going to hand out some scissors. I want you to cut these out. When you're done cutting them out, just like look ready to go, and I'll tell you the next step. All right, once your triangle is cut out, I want you to pick any side of your triangle. And we're going to find the midpoint of that side. So I'm going to take the two end points, the two vertices, and fold them and kind of make a crease right where they match up. Make a crease right in the middle. So I'm picking a side and then I'm folding and just making a small little crease right where they fold. So pick a side of your triangle. And then right like JJ has, just make a little crease or mark it with a pencil, something. So fold two sides together and then just make a little crease on that corner. That's step one. Perfect. So fold them together. Your corner. Okay. Once you do that for your first side, I want you to take that point of your crease, okay, and you're going to fold along that crease. So here's my crease, and you're going to connect it to your vertex. So I'm going to fold a line to connect my crease and my vertex. It's going to be hard. It's going to be a little bubbly, like it's going to kind of want to rise up a little bit. Push down your crease and kind of slide it towards your vertex. Okay? And I'll walk around and help.
Do I do the other one like that?
So, this is Asia's crease. Here's her vertex. I'm going to fold to where they connect. So I kind of put my fingers on both and I fold to where they connect.
Like I did this side. Do I do this side?
I want you to connect these two corners and then crease it right here. Right in the middle.
I'm on mine.
Right now. Okay? Perfect. And then yours is easy. Connect to the vertex and I do the other side. Take a crease and connect that crease to the vertex. Perfect. Yours is like already almost connected too, so yours is good.
Like this?
I want you to do it for the other side. So you did it for this bottom side.
Yeah.
Turn it. Do it for this side. Make a crease. Did you do it, Mac? So connect the corners of your side, just like how you started. Make a crease. And then connect that crease with a fold up to here. Okay? You did this side.
Get out, you're no use.
We're on this side. Connect your corners, make your crease, and then connect it up here. Let me explain this again. Step one, everybody hold up your triangle. Step one, take two of your corners. Hold them with your fingers. No one's holding side Lexi. Okay, step three, put your fingers together. Switch to one hand. So now where my two fingers are, I'm holding it with one hand. And then you make a crease. Pinch. Just pinch the corner. So again, I started here. I put my fingers together. Hold it with one hand. Pinch the other side.
What's the next step?
Once you have that, you have your little crease. Okay? I'm going to take that crease. Here's my crease. And take the point across from it and make a fold to connect the two. Mine looks like it's easy because I already folded it. Yours will have a little bubble. So Lexi, give me yours, or Asia, give me yours.
You can have mine. I'm sure you do mine.
Asia's faster. Okay. Here's Asia's crease. Here's her vertex. She's gonna pinch her crease, pinch her vertex, and kind of slide along to connect the two. Okay? She just made a fold to connect the crease and the vertex. If it's easier, mark that crease with a pencil instead.
Did I do
Okay.
mine? Did I do it?
You did step one. You made your crease. Now you gotta connect this crease to this point. So put your finger on the two things that you need to connect. Hold it.
Didn't we just do that?
Huh?
Isn't that something?
I mean, your triangle, the way that it works out, it is almost perfect. where you don't have to match it back up to your vertex. So now I want you to do the same. Once you're done with one side, I want you to do the other 3 sides, or try to. Okay. Here's another example. Here's Wasim's crease. Okay? He folded his corners in half and he got a little line right here. We need to connect. Right now this line does not connect to this point. It needs to connect over here. So I'm going to hold my middle point. I'm going to hold my vertex. And I'm kind of just going to fold so I can make a line that is connecting both of them. So I'm folding to connect my 2 fingers.
Maybe stay through the line.
Yeah, or if you need to make a crease and then draw a line and fold across that line, that might be a good idea. Okay. Okay, so now you need to draw a line from here to your point and then fold across that line.
I think I
So here's your point, good. I want you to draw a line from here to up here, and then fold on that line. And repeat it 3 times.
What? Is the line supposed to be straight up?
No, you drew the line, so just fold on the line. Just fold it right where the line is. Okay? And I want you to do it for all the other 2 sides. Yours basically lined up off of your first fold, no problem. Not all of them do. Yours did. Good. I want you to try to get those ones. So match up in the corners so you can find the middle. There's the middle. And then I want you to connect that all the way up here with a line.
So where?
All the way up to this point. You're connecting the middle to the opposite point with a line, draw a line, and then fold on that line. Just like a little thing. This is good, perfect. Let's for this one, found the right crease, good. You'll have to connect this point all the way over here. Okay. And then this point, all the way over here. Okay. And then here. Okay, I'm gonna do one more from scratch so we can all try to figure this out. Step 1, cutting my triangle. Okay, triangle. Step 2, I take 2 corners and I connect them. Okay, they're connected. And then I'm just gonna kind of mark on the other side, the middle. What I'm pinching over here represents the middle of this bottom side. Okay? Then, this is where we got stuck. I want you to take that middle dot, here's my middle, and I want you to just draw a line all the way across your triangle to the vertex, and my line is absolutely terrible. But I want you to draw a line, connecting the middle to the vertex. Okay, so draw a line, take your paper, and just fold on that line. Increase it really, really good, because that's one of your medians. Okay, so this is what you have. You did it for the bottom side. Now you have to do it for the other 2. So turn your paper, pick 2 new corners, and restart the process. So connect them and pinch the middle. So here's the middle. Unfold. And if you look, I just marked the middle of this bottom side. Okay? I now have to connect that middle to the opposite vertex. So all the way across. And I'm going to draw a line that connects those 2. Middle all the way across. Obviously, my lines are not nearly perfect enough. And then you fold on that line. Take it and fold on it. Put the crease right where that line is. So now you have one crease here and one fold here. So that's 2 total. And then you do it again for the third side. So find the side that's not marked in the middle. Mine's this side. Fold your corners in, connect them. Put a little crease to mark the middle. Okay. Unfold. I now located the middle, the midpoint of this segment. And now I need to draw a line and connect it to the opposite side, or the opposite corner. And then once I draw that line, fold on that line. Raise your hand if you were able to get all 3 lines. Okay, try to balance it on your pencil. So try to take your pencil, put your pencil right in the middle, right where all 3 of those lines touch, and try to balance it. This one's obviously not going to work because my folds were terrible. Not bad, JJ. Oh, it will work. Ooh. Put it right on that point. That's pretty good, Shashi. Mars is good. Very nice. Okay. So that's your centroid. Okay, it connects all of your medians. And it is also the center of mass. The centroid is one of the cool centers that actually has that center of mass property. So, okay. That's it for the triangles for now. We can mess with them later if you want to fix yours and make it work. But let's go back in our notes. I want all Chromebooks closed. All Chromebooks closed. And we're going to look at, so one property is obviously the centroid is the center of mass. That's what we just discovered with our triangles. The second property is the one that we'll actually use more in this class. And the way I'm going to show you that property is through GeoGebra. GeoGebra. So what I have done here is I drew a triangle. And I marked all the midpoints. So just like when we took our triangles and we folded them to mark the middle, that's what I've done here. I marked all my midpoints. Now I'm going to draw my medians. Okay. Those are my medians. So if you want to draw those on your paper, this should be that diagram at the bottom of page 5. Okay. Here is my centroid. It's where all my medians intersect. Okay, that's my center of mass. And now I'm going to measure kind of each segment that I have here. I'm going to measure this one, and basically my centroid to the outside of my triangle. I'm going to measure all of those pieces. Okay, GeoGebra does it for me. So I measured those pieces. Does anyone notice anything about the pieces? More specifically, here's a median. One of its chunks, its pieces, is 3.2, and the other piece is 6.4. What's the relationship between 3.2 and 6.4? It's half. 3.2 is half of 6.4. Okay? Let's see if it works for the other medians. If I look at this one, this is, I don't know, about 6.5 and about 13, if we're not dealing with the decimals. That's half. This piece from the midpoint to the centroid is half of the centroid to the vertex. Okay, Bella? Yeah. So that's what we kind of discovered. And in general, each median can be split up into thirds. We have a third here. We have a third here. And we have a third here. Okay, we can kind of relate everything back to this smaller piece because our bigger chunk is just 2 times it. Okay, so that's what we're going to do. This median centroid theorem that we have is based on the idea of thirds and that all of our medians can be broken up into thirds. Okay, so what we just recognized in GeoGebra was that from the vertex to the centroid, so from the vertex to the centroid, if we count our thirds, this was 1, 2 thirds of my whole median. So this piece right here was 2 thirds of the whole. The other smaller piece from the midpoint to the centroid was 1 third of the whole. And that is our first theorem for today. This is also probably one of the harder theorems of this chapter, just because it deals with fractions and like there's multiple things going on at once. So this theorem on the next page should definitely 100% go on your cheat sheet. Okay, but we call this theorem the centroid theorem. So in this picture, I drew a triangle and I drew its medians and I marked where they intersect. That's P, point P. The centroid theorem tells me that my medians intersect at a point, my centroid, that is 2 thirds of the distance from each vertex to the midpoint. That's a more complicated way of saying exactly what we set up here. This piece is 2 thirds of the whole, and this piece is 1 third of the whole. Okay? So again, don't write this theorem word for word on your cheat sheet if this doesn't make sense to you, but this does. Then just write this. Okay? So, if we look in our picture, there's kind of a few options. I'm just going to first point out this median right here. Okay? Which piece looks bigger? BP or PF? Which one?
Yeah.
You think PF looks bigger? BP looks bigger. And you're right, it is. From the vertex to the center is bigger. It is double. BP is double 2 times the other piece, PF. That's one thing our theorem tells us. Okay? Vertex to the center is double our midpoint to our center. Okay? We can also kind of relate everything to the whole thing. So if I look at BP, well, here's 2 thirds. Here's where our other 1 third was. So BP is 2 thirds of the whole. And the whole thing is BF. Because just like what we did up here, I can kind of split my bigger chunk into 2 of my smaller one. And then my whole segment gets split into thirds. Okay? So we have the big one is 2 thirds of the whole. And we also have the small one, PF, is 1 third of the whole. Okay? That's what this theorem tells us. And that's true for all of our medians, not just the yellow one, but all 3 of them. Okay? Here's the trick that I want you guys to use if you are not confident working with fractions. So, depending on what information you're given, I want you to work these problems differently. If you are given the small piece, okay, so you're given right here, PF. Then, to get to the big piece, I want you to multiply it by 2. So I want you to do 2 times your small piece. Okay? And to get to the whole piece, W, let's call it, I want you to do, well, if we look at our thirds here, here's my small one, and I have 1, 2, 3 of them to get to my big one. So I want you to multiply your small one by 3 to get the whole thing. Okay? If you're given the big piece, well, how do I get from big to small? What do we think? The big was 2 times the small, so how do I go the opposite direction? If the big one's 10, what's the small one? 2 times what gets you 10? 5. Okay, how do you get from 10 to 5? You divide by 2. Okay, so to go from big to small, you take your big piece and you divide it by 2. Okay? And then once you have the small, we can just do the exact same thing we did before to get the whole. 3 times the small. In general, let's always try to get the small piece first if we can. Okay? Everything relates nicely to the small. Not everything relates nicely to the big. Okay? So try to get everything down to the small. So if you start with the whole thing, again, here's our whole thing, and we need just a piece of it. And there's 3 of those pieces. So I can divide my whole thing by 3 to get just 1 of those pieces. So I take my whole thing and I divide it by 3 to get the small piece. And then once I have the small piece again to get the big, I just multiply it by 2, just like what we did up here. Okay? These aren't necessarily things you have to write on your cheat sheet. They're not necessarily things you need to memorize. But if fractions confuse you and seeing like part of a whole picture is confusing to you, these will help you. They're shortcuts. They tell you the formula no matter what. Okay? So let's try to use them. We have these 3 examples. It says BD, so this whole thing is 24. Okay. Does BD represent the whole thing, a big piece, or a small piece? What do we think? Is it the whole median, or does it stop in the middle? It's the whole thing. Okay. If we start at the whole, I need to immediately try to get to the small. The small piece is right here, ED. And again, I can split my whole piece into thirds. So ED is going to be 1/3 of my whole piece. Just like my formula up here. To get my small, I divide my whole thing by 3. So for my small piece, I get 8. Once I have my small piece, how do I find my big piece? What do my instructions say up here? What do I need to do to my small to get my big? Multiply by 2. So BE is going to be 2 times 8. BE is my big piece. So it's going to be 16. And I know I'm right because these 2 add to 24. They're half or double of one another, and they're 1/3 or 2/3 of 24. But notice how I didn't deal with any fractions. I didn't say, okay, my big piece is 2/3 times 24. We're kind of trying to skip that if we can. Okay? That's why we go to the small piece first, to skip the rest of the fractions. So this one tells us JK, this piece right here, is 4. This goes from the midpoint to the center. Is that the big piece or the small piece? It's the small piece. Okay? Small piece is midpoint to center. Big piece is vertex to center. So we have the small piece. That's the best one to have. Let's find the big piece. That would be KG. How do we go from small to big? Multiply by? Small to big. Multiply by 2. So 2 times 4, we get 8 for our big piece. For the whole thing, you have options. You could either say, okay, the whole thing is going to be 4 plus 8. Or you could say 4 times 3. You have options. But our whole thing here is going to be 4 plus 8, that's 12. Okay? Questions on that one? Okay. One more of this type. This one says QN is 20. So this piece right here is 20. Is that the big piece or the small piece? It goes from vertex to center, big or small? Big. Okay, so this is the big piece. We need to get to the small piece. The small piece is PQ. To go from big to small, what do I need to divide by? Here we multiplied by 2. What should I divide by to do the opposite? 2. Divide by 2. So 20 over 2 is 10. So my small piece is 10. Which means my whole thing, if I add those together, 20 plus 10, I get 30. Questions on that one? Okay, there is for sure one of these on your test, maybe more than one. I would write one of those examples on your cheat sheet. Okay? This next example is also a good one to put on your cheat sheet for the same reason. This one we're now dealing with centroids on the coordinate plane. So this time we're given a triangle with these vertices. So let's graph them. Let's graph 2, 1 right here. That's R. 5, 8 is up here. That's S. And then T is 8, 3 right here. So here's the triangle that this problem's talking about. And it says, find the coordinates of the centroid. We talked about how the centroid is like the true center of mass, center of gravity, center of everything for this triangle, okay? We also talked about the center for segments. We called it a midpoint. Does anyone remember how to find a midpoint? What our midpoint formula was on a coordinate plane? What did I do with my points? This will show up on your final, so if you don't know this, put it on your final cheat sheet. But your midpoint formula was x1 plus x2 over 2. Remember the average of your x's and the average of your y's. That was for the midpoint, the average of 2 points. But for our centroid, we have the average of 3 points. So we're going to add up all of our x's and we're going to add up all of our y's. But instead of dividing by 2, we're going to divide by 3. So this is another formula that should go on your cheat sheet for this unit, the centroid. To find the coordinates, you add up all your x's, so x1 plus x2 plus x3, and you divide by 3. You find the average of your x coordinates. And then you add up all your y's, and you find the average by dividing by 3. And that's your x and y coordinate of your centroid. Okay, very similar to the midpoint. We just have the average of 3 points instead of the average of 2. Okay. So let's try that for this example. My x's, if I look, it is 2, 5, and 8 for all of my x coordinates, 2, 5, and 8. So I'll add those up and divide them by 3. And then my y coordinates are 1, 8, and 3. So I'll add those up and divide them by 3. Okay. 2 plus 5 is 7. Plus 8 is 15. 15 divided by 3 is 5. So the x coordinate of my centroid is 5. And then same thing over here. 1 plus 8 is 9. Plus 3 is 12. Divided by 3 is 4. And if we actually plot that point, it looks good. It looks like it's in the center. And I actually, in my personal notes, I went through and I actually found the midpoint of all of those and the equations of the lines to connect them. And it's accurate. Okay, so your centroid, use this formula. It needs to go on your cheat sheet. Questions on that one? There's one like it on your test. Okay, we have one more centroid median problem, and then we have one more segment to go through, and then we're done. So, last one for medians. It says BD is the median of ABC. And it says AB is x minus 7. It says AD is x plus 3. And DC is 2x minus 17. And we need to find AB. So we need to find the yellow piece. Okay. What do we know about medians? What does the MED, median, part of median, remind you of? What's special about this point right here?
D.
Yeah, what's special about D? What does it do to this whole segment? It bisects it. So these two segments are congruent. D is my midpoint. That's the definition of a median. It connects the vertex to the midpoint. Okay, so D is a midpoint. So if these two segments, AD and DC, if they're congruent, what should I do with the x plus 3 and the 2x minus 17? If these pieces are the same, they're congruent. Things are the same in math, we set them equal. So x plus 3 is equal to 2x minus 17. Again, these pieces are equal because the median intersects the midpoint. Okay, solve for x here. Let's subtract my x over. I get 3 is equal to x minus 17. And then if I add my 17, I get x is 20. But the question asks for AB. So what should I do with this 20? Subtract 7 off, aka plug it in to find AB. So AB is 20 minus 7, which is 13. Okay. So this one was just a pure, do you know the definition of median? Do you know that it intersects a midpoint? So that's why that chart at the top of that review packet is super important, because it actually goes through all of the characteristics of all of these segments that we're talking about. Okay? Questions on medians? Okay. The last segment that we'll talk about today is something that you might have heard of before. It's the altitude. The altitude is also known as the height. So in like your area equals 1/2 base times height formula for triangles, it's the height. This H really means the altitude. Okay, so altitude, height, kind of the same thing. But for our purposes, we're going to use altitude. It's special because it is perpendicular to a segment and it connects the opposite vertex. So what that means is, for example, it connects a vertex to the opposite side at a right angle. So vertex to the opposite side, it connects them at a right angle. Okay, this is your altitude. It is different than a perpendicular bisector because one, perpendicular bisectors don't necessarily hit the vertex, and two, they bisect this segment, and the altitude doesn't do that. It may, and it will for some special triangles, but for most triangles, it will not bisect that side. Okay? The altitude can look like different things. Like it's these two. In those triangles, it's inside this triangle. But for this one, to make a right angle, it had to go outside of the triangle. We had to essentially extend this side over here so we could draw that right triangle to connect it. Okay, so altitudes can be inside or outside the triangle. They can also be, for right triangles, they can be on the triangle. Because right triangles already have that 90-degree angle that connects a vertex to a side. So that is the altitude. One of the sides of your triangle is actually the altitude. Okay? So they can be inside, on, or outside the triangles. And what we're going to do is look at what case are they inside the triangle, what cases are they outside, and what cases are they on the triangle. Something else that you won't be tested over, but the point of concurrency for altitudes, that point in the center where they all meet, it's called the orthocenter. So on my poster up here, it just says orthocenter. It doesn't say underneath it says intersection of altitudes. But like this picture shows you all of the altitudes. And we call that the orthocenter. The point of concurrency is the orthocenter. Okay? So in GeoGebra, I have drawn, maybe if it'll load, I've drawn all of the altitudes of this triangle. So all of these angles in here are 90 degrees. They intersect a vertex and the opposite side at 90 degrees. We're going to see what happens when I change this triangle. Right now it's an acute triangle. Is my orthocenter inside or outside my triangle? What do we think? Where's that point? Point D, is it inside or outside? Inside. Okay, so for acute triangles, no matter what, if they're acute, this is still acute, this is still acute. For acute triangles, they're going to be inside your triangle. Okay, just like over here, our altitude was inside. And that the intersection of all the altitudes is also inside. For obtuse triangles, let's make this angle a little bigger. What happens? Where did my orthocenter go? Where's that point? Inside, outside, or on? It's outside now. So as our angle got bigger, it's outside our triangle. And then for right triangles, your altitudes would all be the sides of your triangle, and it would actually be on the triangle for the orthocenter. Just like how your altitude for right triangles is actually one of the sides. So right triangles are the one where it's a little bit weird. The altitude is kind of already given to you. Okay. Questions on altitudes. They make a right angle. They hit a vertex. I would put a big star next to this example. There's one very similar to it on your test. Okay? This one just straight up uses the definition of altitude. It says find BC, so find the length of this whole segment, if AD is an altitude. Okay, let's remind ourselves what altitudes are. Altitudes are perpendicular and they hit a vertex. Can someone remind me what perpendicular is? What does it mean? If AD, my altitude, is perpendicular to BC, what's special about this angle right here? What type of angle do perpendicular lines make? Huh? A right angle, a 90-degree angle. Okay? So this yellow angle, this 4x plus 10, has to be 90 degrees. So I'm going to set it equal to 90 degrees because it has to be perpendicular. So 4x plus 10 is equal to 90. Solve for x by subtracting 10. We get 4x is equal to 80. Solve for x by dividing by 4. We get 20. But the question wasn't asking to find x. It said find BC. So I'm going to take that x, that 20, I'm going to plug it into this entire segment BC. So into the 3x minus 4 and the 2x. So BC is equal to 3 times 20 minus 4. That's this piece. Plus 2 times 20. 2 times x. Okay. And if I simplify this, this would be 60 minus 4 plus 40. 60 minus 4 is 56. Plus 40 is 90. 96. Sorry, 96. But there is one very similar to this on your test. And I promise you, half of you are going to immediately say 3x minus 4 is equal to 2x. That's not the case because it doesn't necessarily bisect. Okay, you have to use your right angle. So, I promise you someone on your test is going to set those equal. Don't let it be you. Okay? One last thing, and this is kind of past our scope for this class, but for a cool fact is for isosceles triangles, so when they have two congruent sides, your perpendicular bisector and your angle bisector and your medians and your altitudes are all the same. So that's why, like, on some of your triangles, you were like, I don't know what other segment I'm trying to, like, fold and draw here. It's because you already drew it, because it was the same as just, like, finding one of your perpendicular bisectors or medians, okay? For equilateral triangles, any of the segments we talk about this chapter are going to be the same, which is pretty cool. But questions over today at all? You need to know your 2/3 and your 1/3 rules, and you need to know that altitudes make a 90-degree angle. Okay? Okay, the rest of the time you have for homework. Majority of you, like more than half, like everyone besides maybe 2 or 3 of you, did not turn in homework from before your snow day. So that's step 1 is your 6.1 homework. Step 2 is 6.2 homework. Step 3 is kind of up to you. You can either start on your learning check for these 2 sections, or you can start on a cheat sheet for this test or for your final. Okay? That's what I want you to be working on, homework or cheat sheet.